All right. Hello, everybody. Good to see you. Welcome back. If you're in my class, good job. You're catching up. If you're from the internet, welcome. Welcome to my channel. Okay, let's start with a joke. How does a penguin build his house? Igloos it together. Igloos, penguins, ice, houses, igloo. Okay. All right, let's share screen and let's get to it. All right. So today we are talking about finding areas by integration. Okay, now we've been leading up to this and we've been working towards it. Now is where we put it all together. Okay, now the area is any or all area bound between the function, axes, and boundary values. And so generally, in general, okay, now sometimes it'll be the area above the y-axis or to the right of the y-axis. We'll talk about those in a moment. We'll have an example there. But in general, when we're doing an integration, finding area under a curve, it's going to be this. Your total area is going to be the areas above the x-axis plus the absolute value of the area below the x-axis. Okay, because as we remember, anything above the x-axis tended to be positive, and anything below the x-axis tended to be negative. So what that means is we don't want any negative areas. We're just going to take, okay, we know that there's an area, we know that it's negative. We're just going to take the positive value because we're talking about area, which is positive. Okay, now I've just written these steps here and I'll talk to you about them, how I actually use it. But with these questions, I tend to do three things. Okay, the first thing I need to do is whatever function they give me, I sketch it. After that, once you sketch it, you can start to see. And what I put for my second step is you want to identify the integrals that you have to evaluate. Okay. Now, once you've identified the integrals, part three, you just got to answer it. Or in other words, you got to do the long, hard yards of integrating, substituting in, all that stuff. Now, for today, to keep it short and sweet, I'm not going to go through the actual integrals. I just want to make sure that you guys can get to your first, I guess, almost get the right integrals. And then from there, if you need to relook at how to do integrals, go back and watch one of my later videos. Okay, cool. So let's start by this, okay? Areas bound by the x-axis. This one will by far be your most common question. All right, y does not come up nearly as often, but you need to know it because sometimes it does. So for this one here, they've given you a question and they'll just say something like this. And heads up, I've given you a slightly more difficult question, okay? Okay, areas bound by the x-axis, find the area enclosed by the curve y equals to x, bracket x plus 1, bracket x plus x minus 2, and the x-axis. First things first, I need to remember how to graph this. Okay, so from here, I'm looking at this and it's nice that it's factorized. I can see that I'm going to get an x-intercept of 0. I can see here that I'm going to get an x-intercept of -1. I'll write this down here. 0, -1, and here I'm going to get an x-intercept of 2. So I'm just going to write this down. I know I'm going to have an x-intercept at 2, or maybe let's spread ourselves out a little bit, hey? So let's say that's 2. I know that's 0, and I know that's going to be -1. Okay. Now, if I expanded this out, I would get a positive x cubed because I can see here that x is positive, the x in x plus 1 is positive, and the x in x minus 2 is positive. So positive times positive x is going to give me positive. So I know immediately that I'm going to be a positive value, and I know it's probably going to come down this way. All right, so it's going to go back up through the 0 because it cuts through there, and then it's going to cut back at the -1. So that there will be my function. Surprise, we're done, it's graphed. Okay, now what I have to do is I have to identify the integrals that I have to do. I apologize if you hear something in the background. I think there's someone cutting some grass. Okay, so to find the area enclosed by the curve, I can see here that these are the areas that are actually bounded by the curve and the x-axis. Right, there's no point me doing all this area here or all this area down there because it's not bound by the x-axis. These little areas in here that kind of are in between the function and the x-axis, that's all I really care about. Okay. Now, what I'm doing here is I need to write down what these integrals are. Okay. So let's actually work at getting the integral. So for the first integral, I'm going to look at this section here. Okay, I can see that I'm integrating between -1 and 0. And the curve is just that function that we're given, x bracket x plus 1, x plus 2 dx. Now, because it's above the x-axis, it's going to come up positive. I don't need to change anything about it. That's fine. And now I'm going to add the second part. So here I can see the integration. I'm going to be adding this part now. Okay, working on this part here. Now I'm working between 0 and 2. And again, it's going to be the same function, x bracket x plus 1, x plus 2 dx. Now this one here, this area is actually below the x-axis, so that's going to come up as negative. So guess what? I'm going to put integrations around. Oh, I'm not going to put integrations. I'm going to put absolute values around it. And that there is going to help me out with my making sure that I actually add the areas together. Now at this point here, you would just go ahead and you would integrate. All right, and I'll write this actually down here. You know what? I'm not going to do that. That can be an exercise. If you were in my class today, you would have seen it beforehand and someone would have taken a photo. It'll be up there in Classroom. If you guys are online, you know what? You're kind of on your own here. So good luck in actually trying to integrate, but this is not going to be a lesson on integration. This is just going to be a lesson on finding the area under the curve. Okay. So here we're bound by the x, and so it makes sense. Let me make a note here. If we're bounded by the x, look, we're going to go by dx. Okay, but let's take a look what happens if we go and find areas bound by the y-axis. It's going to be slightly different. Okay, now it says here, find the area enclosed by the curve y equals x cubed, the y-axis, and the lines y equals -1 and y equals 2. Okay, so let me draw that. That is roughly y equals x cubed. And this time we're going with the y-axis and the lines y equals -1. So let's say that's -1 here, y equals -1, and y equals 2. Let's go 1, 2. All right, so if I'm finding the area that's now bound between these and the y-axis, I'm actually now looking at this area in here. I'm trying to find it. Okay, so that is the area I'm looking for now. Now, see how it's different from the previous one? This previous one is we're bound by the x-axis. This time we're actually going to be bound by the y-axis. So if we're bound by the y-axis, immediately I need to be thinking, oh, I'm probably going to integrate with respect to y rather than with respect to x. So that tells me I actually have to change, and I'll write this down. Change y equals to x cubed to make x the subject. Okay, that's all I'm trying to do. So if y equals x cubed, x is just going to equal y to the power of a third. And that there will be my equation. So now, if I take a quick look here, my integrations that I'd have to solve, and let's break it down bit by bit. Okay, and let's also not forget that that middle there is always going to be 0. So let's deal with this first little section. Let's deal with this section here. Now I'm going to draw a vertical line so you can see where I'm going in between. Now that integration there will be between -1 and 0. And I'm not going to use x cubed because I'm not integrating with respect to x anymore. I'm integrating. I've lost it. Integrating. All right. We're integrating the y this time with respect to y. Okay, so that there will find our first little section. Now, because this is technically in the negatives, this is the part here that's going to become my negative area that's below that, I guess, or to the left of the y-axis. So that's going to become negative. If I want to find the area, I need to make it positive. And if I'm going to add the integration here, I'm going to add the integration of, this time I'm going between 0 and 2 this time. Okay. So now I'm looking between 0 and 2, all that area there. And I'm going to get Okay, it's still going to be, this time it's going to be between 0 and 2, as we can see, but it's still going to be y to the third dy, right? And that there is it. I've broken it down into the separate pieces. All the negative pieces, I've taken the absolute value and I've made positive. And everything that's, positive already, I just added on. Okay, now the only difference is if I am enclosing the curve with the y-axis and the y lines, that means everything has to be y this time. All right, so as you can see, that is y. These values relate to the y's, okay? And if I was dealing with x's, all these values, right, x equals -1, x equals 0, x equals 2, all these negative values now become, or all these values, sorry, now become my bounds. Okay, so if you're enclosing it with the x-axis, everything's in terms of x. If you're enclosing by the y-axis, then everything's in terms of y. Okay, now hopefully that makes sense and hopefully that helps, but I will catch you guys another time. If you need help with the integration, I think someone online may have posted the solutions. I'm going to say that for another time, but anyways, enjoy and I'll catch you later. Alrighty, bye.